Now we are going to move on to the next chapter, chapter 11, which is going to cover area. So we're first going to review area of triangles, parallelograms, trapezoids, rhombi, and kites. So the very first thing you need to be aware of is that everything will be in units square because area covers flat surfaces. So it will be square feet. So if you were painting a wall, you would need to buy paint to cover the square footage of the wall. So I know you have done area before and you've done area of polygons before, but in geometry you have to rely on background knowledge to help find missing pieces. So the first thing that we have listed here is the parallelogram. Now the height of the parallelogram is always going to connect the parallel bases. So notice how this is connecting. It's 90 degrees, that's the shortest distance, and you have the base. Now, if you rotate this till it looks like this, and then you've got the base here, then the height is going to come outside and drop 90 degrees, and that's going to be your height because it's connecting this base to this base perpendicularly. Next is a triangle. A triangle is basically just half of a parallelogram, and that's why you've got 1/2 base times height. Over here, we had just base times height. So the same concept, you need to connect one vertice down to the base perpendicularly to find that height, and that's the base. So whatever base you're using, you have to drop that altitude down. Now trapezoids, what makes a trapezoid special is that it will have two parallel bases. So here's base 1 and base 2. This one here is a different looking one, but you still have parallel bases. The height is always going to connect the parallel bases. So make yourself a note that the bases are always going to be parallel. The formula is going to be 1/2 times the height times those bases added up together. Okay? Now, the ones that you're probably not as familiar with would be the rhombi and the kites. Now, this is some background knowledge you need to know from quadrilaterals. And quadrilaterals is going to be that the diagonals are congruent. The diagonals are congruent. Okay? So since the diagonals are congruent, that's going to make right triangles in there. So here, that's a rhombus. This one right here is a kite. A kite has these congruent and these two tails that are congruent. So when you look at this formula, it says simply 1/2 diagonal 1 times diagonal 2, and you can see how the diagonals are labeled. Now, how this is going to be different than what you're used to, you will be using previous knowledge, the Pythagorean theorem, your right triangle trig, your 30-60-90, your 45-45-90. Because you notice in every picture here, the 90-degree angle pops up. Now, we can also look at area for composite shapes. Now, a composite shape is just a bunch of shapes made up into one. So to find the area of a composite shape, you add up the areas of the smaller shapes. So for example, in this first picture, you have two identical rectangles. So you would have two of those, and then you would add together this square in the middle. This funny looking shape here has this quadrilateral, this triangle, and this triangle. Or you could even, if you had the right information, combine this for one big triangle. So it just depends on how you see it to break it up. So now let's go ahead and look at number 1. It says find the area of the triangle, and I give you a hint. Use triangle knowledge to find the height. So previously, you would have just been given everything. But in this picture, you are given two little things. You're given that this is 6 and this is 14. So what that tells us is we know the base. We know the base, then that's going to be 20 centimeters. What we don't know is the height right here, because that's what's connecting that. So before we can proceed, we must find the height. Well, if you will look closely, you should be able to see that we are dealing with a right triangle in the special case where an altitude is dropped from that. So if you remember your similar right triangles, then we have a rule for this. Do you remember this? We called that heartbeat, but it's the geometric mean theorems. So to find h, we can say 6 goes to h like h goes to 14. It's similar right triangles. So we're going to get h squared equals 84. Square root both sides. H equals, I'm going to break this down by 4 and 21. That is going to give me 2 square root 21. Now, the question says find the area of the triangle. So the area is 1/2 the base of 20 times the height of 2 square root 21. So 1/2 equals, the 1/2 will cancel out with this 2. So 20 square root 21 centimeters squared. Always remember your units. Now, question 2 says find the area of a trapezoid. Now, hint, use trig ratios. Now, the trapezoid, we need to know the height, and if you look at this picture, we do not have the height. The height could be here, or the height could be here. Now, when we do that, notice that that's going to make a 90-degree angle right there. And if I'm telling you to use trig functions, could we even use the 30, 60, 90 rule? Okay, well, I don't know if we can or not, but we can sure try. If this is 16, that makes this one 30. So this is going to be the short side here. The hypotenuse, if you remember, is always half that. So that's going to be, or double that. So I'm going to make this one right here an 8. And the long leg is going to be 8 square root 3. So we actually didn't have to use trig functions. We used our 30, 60, 90 rules. So the height is 8 square root 3. Now the short base, this one's up here. This is the short base. Because now what has happened, this is now 8 and this is 8 and the total is 30. So in order to find this short base, we can say 30 take away 16, and that is going to give us 14 for the short base. So the area of this is going to be 1/2 the base, or the height, let's go ahead and put the height in, times the bases added, so 14 plus 30. So I'm going to come over here, and I'm going to say, okay, 1/2 of 8 square root 3 is 4 square root 3 times 44. So I can put those beginning numbers together, those coefficients. I'm going to get 176 square root 3 square inches. And if they ask us to round it, we would, of course, type that in our calculator.